back. I screwed the cover on during the intermission. Why waste time taking a video of that? All right, so here's the final package, and now we'll do a little demonstration of show and tell. The easiest thing to do is just turn it on, and we'll show you the push button. And if you look against the wall, to the center of the screen, pretty close, whatever, you can see that I'm okay, so that activates simply by pressing the button. I can plug in an MP3 player that has some pre-recorded code on it, Morse code in the case of this test. Or I can plug in my oscillator, my super duper, and if again you look against the wall, you'll see that it's pulsing. Right now I have it set at 10 hertz, pulsing at 0.01%. I can pulse it at any rate I want. This oscillator will go down to 1/100th of a second, which is, it'll take 100 seconds for one pulse to pop out. You can control the intensity with the duty cycle if you have an oscillator such as this or something similar. One that I will be making available eventually. Get my hand out of the way, or just move the oscillator. Yeah. And I'm going to change the frequency first, bring it up so it looks pretty constant. Now it's at 100, and so the beam looks very constant, and you can see the beam against my hand. It is quite bright. The camera really doesn't do it justice because the camera is running at 25 hertz, I think. Actually, I think it's doing 20 hertz, so it's a little jumpy and it doesn't catch the nice nature of the laser. And I'll switch to duty cycle, and that's 0.01%. 1% of the time it's on, and the rest of the time it's off. And if I start turning it up, you can see it just getting brighter and brighter and brighter. It's really blazing against the wall. Again, the camera does not do it really justice. And if I go back to frequency, I can get it even higher or brighter by increasing the frequency, and now you can see it's a small nova. So that's how you control it with a frequency oscillator. There are a lot of different applications. You can make a simple 555 timer circuit. You could use this as an emergency road signaling device. Green really lights up the sky at night. You can aim it down the road, off the road, not at cars coming at you, and it'll catch their attention. It's got a range probably of a couple of miles easily on a good day. You could also just shoot it up in the sky if you're in an area where the trees wouldn't block the view from the roadside, so people could see a beam shooting up in the sky. That could be a nice emergency signal. You can use it as an astronomy evening sky pointer, which I have done, not with this unit, but with a real just plain laser pen right here. By the way, this is where I cut the laser assembly out of. Unscrewed it, took off the bottom half, and then I took my Dremel tool and just sliced down the side and pulled the assembly right out. They're mounted in there with glue and everything else, so it's not really easy to get out. And I think I have and there's the one from the pen, and you can see that I'm running a little bit more power to the one in the Space Talker. The pen only has a couple of, get it out, Steve, AAA 1.5 volts, so that would total for 3 volts. The Space Talker is running off a lithium ion that ranges in voltage from 4.2 to 3.7 roughly. I've been charging them up with my charger device, battery charger, pillbox battery charger. I just charged this up last night, and it brings it up to 4 volts, 4.05 volts. So the laser actually has a little bit coming out of the box has a little more oomph. As long as you pulse it, you can probably get many, many hours of continuous use. If you just held down the button, I would imagine it would start getting hot at that kind of range, voltage supply. I actually could feel the heat when I was playing with it and testing it and doing some evaluations. I believe the laser is evaluated or given a 3,500 hour lifespan before it pops or dies or whatever. Some of these lasers go up to about 5,000 hours before they're out of guarantee. I'm not guaranteeing anything, I'm just telling you what the manufacturer is telling me. All right, so the next thing to do is demonstrate unplugging the supply. Oh, something I also wanted to point out. When you plug in the charger, it disconnects from the rest of the circuitry, so you're not running the laser off a fixed DC. I did that intentionally to prevent burning out the laser. It had a permanent power supply connected and you were running this full blast. I suspect you could cook the laser. So last night also I did a test on battery length, and I was able to run this with this oscillator, this battery. It ran it for about 10 hours. The first 4 hours were running pretty strong. I was using the MP3 player, which has a way of going on and off for as much as it can. It drives this as hard as it can. Of course, it's a duty cycle thing because Morse code's duty cycle on and off pulses. So the laser wasn't full brightness, but it was at least as bright as a pencil laser. Okay. When you plug in this, it disables the button also. So if I have it on, I turn on, you can see the laser over against the wall, full brightness. Plug it in, pressing the button, and no laser against the wall. Turn on the MP3 player, which unfortunately I should have had this already on. It takes 5 seconds to go on, and it's doing a power-up sequence right now, initializing, and I'm just talking to occupy time, and now I am firing. And you can see the lasers sending Morse code. That's rather whippy Morse code. It's at 5.5. That means 5 words a minute with a Farnsworth speed of 5 words a minute. Go to the Morse code. Go look up Morse code on Wikipedia, and it'll explain Farnsworth in a little more detail. I'm going to switch it and get it going a little faster. I have 4 programs on here. This is 5 with a Farnsworth of 15. Much better code. But what I found that the optimum code is around 1218. I can read that. It's really nice. So you can get yourself an iPod and you can flash it down across the football field or whatever, and if they can capture the beam or just see the light, basically. The iPod they have iPod programs that have the capability of decoding this Morse code. There's a lot of programs out there. We're running at 12 words, 18 Farnsworth. So it's almost, the code characters are coming across. 18 means it's coming across. Farnsworth 18 means the characters are coming across at the rate of 18 words a minute. But the spacing is set for 12. I'm using a let me see, I got 500 down here. That means that I'm sending a wave pattern oscillating at 500 hertz. And the circuitry in here, the retriggerable, monostable, and everything else like that, converts that to nice pulses that the laser just loves to see. So what would you send for messages? Now I am going to tell you something, and let's see, do I have enough? Yeah, I'll do it in a minute. I'm going to tell you something and you can laugh. And that's good, because laughing is a very healthy thing to do once in a while. Builds up the immune system. So I decided, why would I call it a space talker? Because I want to send a message out to space. And hence it's going to be called a space talker. What's my message? I've written several messages. On the website, I will, with humor, hopefully it's looked at with humor and I don't get a lot of emails criticizing what a nut I am. I made up a message, and that'll be my first message that I send out in space. Who would watch it? Possibly the space station could see it, and possibly visitors. Okay, so this was pretty simple, black and white. Go to the website. You can see the pictures that I've taken. You can rewatch these videos if you're watching them already or already there. Explore the website, and you can get a little more detail on the Space Talker. So this is, oh, by the way, the Space Talker doesn't care how fast you run the code. I just couldn't read it beyond 20, and actually I have it going at 20 if I flip this to the next program, and for what it's worth, it just switched to 2018, and that's about my limit. Oh, and one of the other things I thought about, this would be an ideal training tool. So you take the output from your MP3 player and do a splitter, pump one into the laser and one into a set of earphones. So now you could learn Morse code by seeing visually and hearing at the same time. A little sensory overload possibly, or saturation, or whatever. Something makes me think that that would help train the mind to be able to read Morse code much more quickly than just listening to sound. I was in the Navy, and we sent Morse code. I didn't. I strictly was radio. But we had people that would send it by flashing light from ship to ship. And by the way, that was many, many years ago. I was in the Navy back in the 60s. So, okay, that's my story. I'm sticking to it. I hope you enjoyed this little presentation, and we'll catch you on the next project.